Hello and welcome to Tribetopper. I'm Sonal Gupta, and this channel is about increasing your understanding of physics. To clear your concepts, subscribe to our channel and click the bell icon for latest updated videos.
In this video session, you are going to learn about the emission spectrum. So to understand emission spectra, we need to understand one thing, that when the electrons they are existing in the higher states, in the higher energy states, when they move back, they transit back from a higher level to a lower level, they emit a photon. Only then it is possible for them to jump back. So when an atom makes a transition from energy to a state of lower energy by emitting a photon, it emits a particle of light. And the energy of that emitted photon is equal to how much? That has to be equal to the difference in the energy between the two levels. So if we say that an electron jumps from the level, it makes a transition from the level n is equal to 3 with an energy of minus 1.5 electron volt to the level n is equal to 2 with an energy of 3.40 electron volt, then how much is the difference to go from this level to this level? So that gap is equivalent to, so when you subtract the two energies, you get 1.89 electron volt. So this much is the energy gap between the two levels. So this electron in the state n is equal to 3 has an energy by an amount 1.89 electron volt extra energy. So when this photon is emitted, it is of energy 1.89 electron volt. But we'll convert this energy into joules. So energy gap has an energy of 1.89 from electron volt. You'll convert it into joules, means you multiply with 1.6 into 10 to the power minus 19 joules. So you get 3.024 into 10 to the power minus 19 joules. So this much energy is there that has to be emitted for the photon. So now let's make out how much will be the wavelength of that photon, because photon is basically what? A particle of light. So that will be emitted as a tiny flash of light. And when those tiny flashes go together, like you can see here, you get a red light. That means some red tiny flashes were emitted continuously, which made us see some continuous visible light of red color or of blue color or of violet color, right? Now which color is emitted, that will depend on that how much will be the wavelength of that emitted photon, right? Now we know there is a relationship between the energy and the frequency of the emitted photon, and they are related as E is equal to HF. Just for your knowledge, if you don't remember, that energy is always directly proportional to the frequency. Higher the frequency, greater the energy of the wave. When we remove the proportionality sign, we get a constant h here. So E is equal to hf. H is a Planck's constant, which has a fixed value of 6.634 into 10 to the power negative 34. So we'll use this value here. But we also know that F is equal to C by lambda. So we will, by the famous wave equation, so we will replace this F. So we get E is equal to hc by lambda. So we can figure out lambda because we know all the other values. So what will be? Therefore, the wavelength of the emitted photon is going to be how much? The wavelength of the emitted photon will be lambda is equal to hc by lambda, hc by E. Now substitute the values. H is 6.634 into 10 raised power minus 34 into C is the velocity of light, which is 3 into 10 to the power 8, upon we have the energy, and we had just found out that energy is 3.024 into 10 raised power minus 19. So 3.024 into 10 raised to the power minus 19. Solving this, we get a wavelength of 6.58 into 10 to the power minus 7 meters. So this particular wavelength will be emitted when an electron jumps from the level n is equal to 3 to the level n is equal to 2 in case of an hydrogen atom. So depending on that in which atom what transition is happening and how much is the energy gap that needs to be filled up. So that much energy has to be given out. So that will be the energy of the emitted photon. So from the energy of the emitted photon, using the relationship E is equal to hc by lambda, we can figure out what will be the wavelength of that emitted photon. So for whichever color, this wavelength will be suitable, that color you're going to see. So this is the hydrogen emission spectrum. So when it is jumping from n is equal to 3 to n is equal to 2, you will get one color. Then from n is equal to 2 to 1, you get another color. So this way, this is the emission spectrum of hydrogen that is obtained. So that's all in this video session. In the next video session, you are going to learn about the absorption spectra. Thank you.